Hello, young scholars. You are welcome. I'm particularly excited to have you in this mathematics class. This will be a concluding part of the previous class, which was bearing and distance. In the last class, we started bearing and distance, where we treated some introductory aspects, talking about the definition and the different notations in bearing, and of course how to change bearing from one form to another. Now, a quick reminder of what we did talk about in previous classes. We've talked about the Pythagoras rule. The Pythagoras rule can be used to find the side of a right-angled triangle provided the other two sides are given. Now, the Pythagoras rule states that the square of the longest side of a right-angled triangle equals to the sum of the squares of the other two sides. We also talked about the trigonometric ratio. The trigonometric ratio is very important when an angle is given in a right-angled triangle. We also talked about the sine rule and the cosine rule. The sine and the cosine rule, however, can be used to solve questions involving the right-angled triangle and any other type of triangle. How are these 4 points used to solve practical questions in bearing? Let's go to see question 1.
Question 1 is on reverse bearing, and it says the bearing of point X from another point Y is 071 degrees. What is the bearing of Y from X? Now I'll carefully choose a point Y where I'll insert my cardinal points and construct an angle of 71 degrees starting from the north in the clockwise direction. Remember that bearing is always counted from the north in the clockwise direction. Then I can draw my line going to the point X. Once I have the point X, I can go ahead to insert another cardinal point and find the reverse bearing. Now the reverse bearing once again starts from the north at point X and is counted in the clockwise direction. Now this should be the bearing of Y from X. But remember, we can have alternate angles. This angle here is 71 and they are alternate angles. But the other part is 180 degrees because it's sum of angles on a straight line. Now how do I get this entire angle? I simply add 180 degrees to 71 and I have 251 degrees. Now let's consider a different form of question in bearing as we have in question 2. From a point Z, 30 meters north of X, a boy runs 40 meters eastward to another point Y. Find the distance between X and Y and also the bearing of Y from X. First of all, I have to construct a diagram from the given parameters. I know my point Z is 30 meters north of X. I will have to insert my cardinal points at X and place my point Z due north of X. And I'll make sure the distance between them is 30 meters. That's my Z, and the distance between them, 30 meters. Now, if a boy runs from Z eastward to another point Y at a distance of 40 meters, when he gets to Y, he stops, and from the point Y, I will have to draw a straight line linking point Y and point X, and that will represent the distance between X and Y. Call that distance Z. Now I realize this is a right angled triangle where I have two sides given and I can use the Pythagoras theorem to find the last side. My Pythagoras rule says my hypotenuse squared equals opposite squared plus adjacent squared. When I place in the values of the opposite and adjacent as 30 meters and 40 meters respectively into the Pythagoras rule, I will find the distance between x and y as 50 meters, and that is the solution to the first part of the question. The second part says, find the bearing of y from x. The angle in question has to be drawn from the north of x in the clockwise direction to meet the line xy. And in finding this angle, I can decide to use either the sine rule or the trigonometric ratio. Let's go with the sine rule. Sine z over z equals to sine x over x. If I substitute that properly, I should have my angle as 53 degrees. So we can safely say that the bearing of y from x is 0.53 degrees. Now the bearing is always written in 3 digits, which is the proper notation of true bearing. Next question, please. This question says that point B is 60 kilometers away from point A on a bearing of 130 degrees, and C is 80 kilometers away from A on a bearing of 242 degrees. Now the question says, find the distance between C and B, and also the bearings of C from point B. Now this question tells us that the bearing of point B and point C are both taken from point A. So first of all, I'll carefully mark out my point A, where I insert my cardinal point, then start from my north in the clockwise direction. I'll draw an angle which is 130 degrees to a point B 60 kilometers away. I'll therefore connect point A and B with a straight line. The next step is to locate point C, which is on a bearing of 242 degrees from point A. So once again at point A, I'll start from the north, counting in the clockwise direction, an angle of 242 degrees, where I will draw a straight line which is 80 kilometers away from my point C. Okay, now that I have my point B and C, I can simply draw a straight line to represent the distance between point B and point C. Now that we have a triangle ABC with 2 sides given, I can simply find the included angle, which will help me to find the distance between C and B. And in finding the included angle, I can simply say 242 degrees minus 130 degrees. That should surely give me 112 degrees. With that included angle, I can now safely use the cosine rule. And in this case, the cosine rule is a squared equals to b squared plus c squared minus 2bc cos A. Putting my values of angle A equals 112 degrees, side B 80 kilometers and side C as 60 kilometers. The distance between C and B, which is side A from the question, will be 116.6 kilometers. And that concludes the first part of the question. Now the second part simply says that what is the bearing of C from B? What is the bearing of C from B? I will simply insert my cardinal point at point B, and starting from the north, I will draw an angle counting in the clockwise direction to meet the line that connects B and C. This clockwise angle is regarded as the bearing of C from B. Now to get this bearing, I will have to find the angle in the triangle B, and to do that, I will either use the sine rule or the cosine rule. Since the sine rule is more user-friendly, let's go with the sine rule. Now, knowing fully well that the sine rule says sine A over A equals to sine B over B equals to sine C over C. In this case, we are using sine A over A because it's a complete pair, and sine B over B because we're looking for the angle B. If I cross multiply and use sine B as my subject, I'll end up having sine B equals to 80 times sine 112 over 116.6. At the end of the day, I will be able to have my B as 39.5 degrees. Now, if my angle B is 39.5 degrees, it is not the same thing as the bearing of C from B. Remember that bearing is always counted from the north in the clockwise direction. So, I will find the other angles, which are alternate angles and sum of angles on a straight line. So, my alternate angle, which is 130 degrees, minus angle B, 39.5 degrees, I will have 90.5 degrees. If I add it to 180 degrees, I have 270.5 degrees. And that is our final answer and the bearing of C from B. Thanks for watching and see you in